replicating the natural scenario, because existing metallic implants, existing implants, they don't mimic the biology, they replace the biology and create their own biology. So, the myths are always solid implants are the best. So we have all understood micro motion is better for a fusion surgery as compared to having a solid immobile segment. Whether a hollow or fenestrated implants are weak, that is again a myth. 3D printed implants, because they have porous structure, they are again weak, that's another myth. And are the mechanical testing always authentic? Cannot be trusted until unless you have a clinical scenario where you have tested these implants. And whether we are capable of doing this research in developing countries like India and Bangladesh, yes, it is a myth that it can be only produced in Europe and US. For that, we have to have a safety and compliance, and we should have a strict clinical protocols which ultimately prove your clinical significance. What are the 3D printed implants? Implants are mainly done in these three formats. One is formative manufacture. You have a mold, and then pour a metal into that, and the implant is produced. And the next is subtractive manufacture, which is like a lathe machine. You thread in a rod, solid rod, it cuts the screw, and the 3D printed implants are through additive manufacture, where a 3D printing implant machine manufactures these by adding layer by layer the metal. So why do we need 3D printed implants? Because you can see there can be a different kind of geometry of patients. Somebody can be tall, somebody can be hefty, somebody can be very thin, some bones are big, some bones are small. So, if you have to have a biomimetic phenomenon, that means if you want to mimic biology, you have to have a patient-specific, personalized, designed implants. So, what it does, it ultimately matches your biomechanical load sharing. It is ideal when you have a deformed spine, when you are doing a revision surgery, when you have a congenital anomalies where the standard implants cannot actually match the anatomy of patients. So, coming to the cages, some of the cages are already in use and we have been using them. So, what you can have in these cages? You can have a specific lordosis, what you want to give into that disc space. You can have a hyperlordotic cages when you want to, especially when you do these degenerative scoliosis patients, where you want to create a sagittal balance, you can have a hyperlordotic cages. You can have long footprints which increases the fusion rates, and when you have a deformed spine, you can have an end plate to end plate contact. So you can see in these lumbar cages, you can have a hyperlordotic cages where you can create a lumbar lordosis. The cage design, the mesh cage design which we have, really is not ideal because they tend to subside very often. So if you have a 3D printed implant, you can have cages such like that which exactly match the anatomy of the patient and decrease the subsidence rate. In cervical spine, you can have a built-in lordosis, whatever you want to the cages. You can have the specific size of cages for the patients. Especially it is useful in